Okay, so now we have a talk by Carlos Arturo Rodriguez Palma from University of Industrial University of Santander. It's in Colombia. And the title of the talk is Polynomial Identity for Subspaces of the Weyl Algebra. So, please.
Thank you, Professor Artem. Good afternoon to the people in Brazil and good evening to those in Italy. I want to thank the organizing committee for allowing me to speak at this event. The results that I will present were obtained joint work with Professor Lopatin from the State University of Campinas, Unicamp. My presentation is organized as follows. First, I'm going to define parametric Weyl algebras. Next, I present some result on identity for Weyl algebras. And finally, I present some result on identity for subspace of the Weyl algebra. In particular, I present a minimal identity for subspace of the parametric Weyl algebra, and I present identity of the degree 4 for the subspace of the Weyl algebra. Okay. First, let if be a field of characteristic P, 0 O greater than or equal to 0. All vector space and algebra are over if. The Weyl algebra is defined by the equality, this equality. Okay? A1 is polynomial algebra in this variable A's way, not commutative, by the restriction y is minus is y minus 1. In 2013, Berkham, Lopez, and Andrews, defined the parametric Weyl algebra by in the following way, in this form, in this way. We can extend the definite with by Berkham, Lopez, Andrews, changing if by fixed ring B, and we obtain the algebra follow. In this case, changing H, 1 by H, where H is polynomial in the variable X, by coefficients in the center of B. And BS is the fixed if algebra wide unity. And this is the F algebra on not commutative B polynomial in the variables H1 Hn. For example, H0 is the polynomial algebra in the variables sheet way with coefficients in if in the if. A1 is the first Weyl algebra. Is the first Weyl algebra. This parametric algebra can be said as one Or station by below first defining of the Or station. An Or station A is given by an unital associative algebra R and if algebra endomorphic sigma of R to R and sigma derivation delta of R to R. That is, delta is F linear map and delta AB is delta A B minus sigma A delta B for AB in R. Then A is the unital algebra generated by Weyl over R, subject to the relation this relation. In this sense, if we choose R, if we choose RB or is polynomial in variable x with coefficients in ring V, and sigma is the identity homomorphism on R, and delta is data by the relation that this equation, then AHB is this Or extension. Is Or extension where ring is beige, the over ips e over do identity homomorphic identity e delta is this relation, is data by this relation. The motivation is that this algebra is of three types. This algebra is isomorphic to quantum plane, or this algebra is isomorphic quantized Weyl algebra, or this algebra is isomorphic algebra parametric algebra AH for some H in this polynomial, this algebra polynomial. We can study the identity in this case, in case 3. Along with some result for identity for parametric Weyl algebra. First, let if is infinite fields, For convention, the leading coefficient of H is not a zero divisor. It's not a zero divisor. The first result in this sense is the following. In the case the characteristic if is zero, the parametric Weyl algebra HB does not have not trivial polynomial identities, but if characteristic of if is different zero, the parametric Weyl algebra have not trivial polynomial identities. In that sense, we can the results following. The result following. If is in case characteristic of if is P difference of zero, if is infinite fields, as identity polynomial of algebra HB are the same by the identity polynomial as algebra of matrix of order P. In that case, if H is not a zero divisor for sign H in center of V. In the case B equal if as identity for the algebra H are the sum identity for the algebra of matrix of order P, but condition H is different of zero. By using this notation, we have the following result. The identities of Weyl algebra H are contained in the identity of the Weyl algebra G matrix or order P. If this condition is held, and the identity of ideals for this algebra are not the sum. It's important that this contain not the same. This convention is very important. It's very important, but not convention. Os theorem 2 and theorem 3 not hard. For example, let B has an if base 1z with C, with square C is 0, and set H is Z. And consider the parametric Weyl algebra A, C, square to if. Consider the Grassmann algebra usual, G of rank K has an if base, this set, and relation this, and this relation. I can prove the result for. I can prove this result for. The si disculpe. If is an infinite field, then the identity for A is square if is generated by F1 and F2. And the identity ideal for the algebras AC square if and algebras matrix of order T for every T for every if algebra C with unity are not the same. The algebra A parametric algebra Weyl algebra A C the square if and Grassmann algebra are P equivalent. That is, they have the same identity. The algebra parametric, algebra Weyl parametric A Z have that some identity for the Grassmann algebra, for the algebra Grassmann algebra. Below was some result for the identity for subspaces of the Weyl algebras. We first defined the Weyl algebra AN. The Weyl algebra AN is defined by this equation, by the ACE equation, where the ideal it is generated by this relation. In the case P is 0, is will know that AN does not have no trivial polynomial identity, but some subspaces of AN satisfies certain polynomial identities. In this sentence, Jumadaidaev studied identity for the following subspace of AN. He considered the polynomial standard or standard polynomial, and he proved the following result for this subspace. He proved in the case P is 0, in the P is 0, the P is 0, he proved that the standard polynomial of degree n is a polynomial identity for this subspace in this condition. And he proved that standard polynomial is degree n is not polynomial identity for this subspace in other case. If 2, 3, 4. Moreover, he's proved that standard polynomial is degree n is a polynomial identity of this subspace for Weyl algebra if and only if n is satisfies this condition. In a work joined with Professor Arten Lopatin, we describe the minimal identity for this subspace H is -1, and in this sense, we proved that for the case is 1, that a minimal polynomial identity for H is -1 have degree 3. We can prove that every homogeneous polynomial identity for H is -1 of degree 3 is a multiplet of the standard identity of the degree 3. In the case characteristic of it is 2, P is 2, we proved that result follow. Is derivative of H respect to variable H is 0 and is even, then the Lie bracket H1 H2 hold in H minus is. In particular, the degree of minimal polynomial identity for this space is 2. If derivative of H is not 0 or is odd, then the degree of minimal of polynomial identity for this space is 3, and every homogeneous polynomial identity for this space is degree 3 and is multiple of the standard identity of degree 3. degree 3 for algún C in if. Moreover, for the subspace, we also study identity of degree 4. In the case is 1. In the case is 1. Below we define partial linearization of if. We define a partial linearization of the multi-homogeneous polynomial if of multigrid delta with respect x e in the following way. In this way. For example, this partial linearization of this polynomial is this polynomial. The result of subsequent application of partial linearization to if is partial linearization of if. The completed linearization of if is the result of subsequent application of partial linearization in the all variables of variables. Okay. We can consider the following. We can consider the following multi-homogeneous polynomials of degree 4, partial or complete linearization of them. This is this polynomial. Then we can prove those results following. The result follow. These three elements are polynomial identities for A1 minus 1. In case P is arbitrary. In case P is 2, these three elements are polynomial identities for subspace A1 minus 1. We also proved that subspace A1 minus 1 does not have multi-homogeneous identity with multigrade 1, 1, 1. Disculpa. There is no trivial multi-homogeneous polynomial identity for subspace H1 minus 1 of multigrade traction is not trivial identity. If is a multi-homogeneous polynomial identity for this subspace of multi-degree 2, then if is a multiplot of identity phi 2. In this sense, we can prove the that for subspace h1 minus 1, I have the if base of the space of all polynomial identity of multigrid 2, 1, 2 in this P not equal to is this set. And is P equal to is this set. Okay. Now consider the following multilinear polynomial of degree 4. These three polynomials. I can prove that this polynomial are polynomial identity for this subspace. This element are polynomial. These two elements are polynomial identity for this subspace. In the case P is 2, then three polynomial are polynomial identity for this subspace. Subspace A1 minus 1. In the case for polynomial of multidegree 1, 1, 1, 1, in the case P equal 2, the subspace A1 minus 1 have if base of the space of all polynomial identity this set. And in the case P is 2, as polynomial identity for this subspace are a linear combination of the following polynomial identities. These are the reference used in this presentation. Those results are this paper. And thank you.
Thank you, Carlos, for your talk. Okay, are any questions or comments? Well, since I was scientific advisor of Carlos, I actually do not have questions about this talk.
Thank you, Professor.